Aloha and share my screen. And put this down here and put this down here. And I am recording. All right, we are in week, this is November 21st. So we are, I've decided to, in doing the exercises for chapters 19 and chapters 20, there's the Visual Studio 2019 or the database or something has changed significantly enough where the files that you're given to start the exercises have errors in them, and two more days is not enough for us to really learn about SQL enough to be able to create our own applications. You've had a good exposure with these two, with chapter 18. You've actually built a couple of interfaces to the database. You've seen where you make adjustments to the SQL statements and so on. And if you need to ever create an application like that, then our textbook is a pretty good source, although you may want to wait for a newer version of it. But text files and binary files are important, and it's more universally important. In any programming language you learn or write code in, you're going to have to read and write files before you're going to have to read and write databases. And so I want to make sure we have enough time to cover reading and writing files, and then after that, after Thanksgiving, we'll go a little bit into XML, and XML is another way of storing data and formatting databases and doing database accesses and so on, and so that'll be worthwhile. So let's start with chapter 21. So I'm going to find some slides here. I hope I have slides for this. Slides. Good. I've got 21 and 22. That's good. Did I download this? I did. I downloaded it already. Okay, good. All right. So you probably remember this from 128, ITS148. We did cover reading and writing text files. So this is the same thing. So this should be a review for a lot of you. So what we're going to learn how to do is develop an application that requires the use of text files or binary files. When we're done with this chapter, you'll understand the differences between text files and binary files. You'll be able to describe the use of these classes, these objects that support reading and writing files: FileStream, StreamReader, StreamWriter, BinaryReader, and BinaryWriter. And you'll be able to describe two common types of I/O exceptions, the system.io classes that are used to work with drives, disk drives and directories and so on, directory, file, and path, and also this this using goes up at the top, which enables you to use these classes. Some of the common methods that we'll be using in the directory class exists that returns true if a directory exists. This allows you to create a directory, and given the name for it, this allows you to delete, and this delete allows you to recursively delete, which means that if you want to delete a directory that's got stuff in it, it allows you to delete the whole directory. And so here's an example of let's say you want to see if this file exists. If this directory exists, on the C drive, you can define a variable called dir, which is set equal to that string, and then you just use this directory.exists, and then as the argument is the string that contains the path to the directory, and if it's true, then if it's in this particular example, if it's not true, then it creates the directory. See that? This checks to see if this is a class that's referred to here. It's an system IO class, and see. Let me do this. Slideshow. Slide. So yeah, this defines a string. Oh, it doesn't work. Why this doesn't work? I need to go like this before it works. Doesn't work. Boy. Oh, look at that. It's terrible. All right. So this will return a true or a false if the directory that's specified by this string variable here, if it exists, it returns true. If it doesn't exist, it returns false. And then so we have a not here. So if this is not true, then create it. And this is a method in this class to create this directory. And some common methods in the file class, similar to the directory class. This returns true if a file exists, and this is a path to the file. This will delete a file. This will copy a file from one place to another. And this will move a file from one place to another. So there remains only one copy with a move, and it disappears from the source path and is stored in the destination path. And copying, of course, makes a copy, so it ends up being in both places. So here's some code that uses file methods. Here's the name of a file. This checks to see if that particular file exists, and in this case, if it does exist, it deletes it. So a text editor or a text file is simply text characters that you can read, and you can use a text editor program to read it, and Notepad is a particular text editor program that comes up with Windows. And here you can see what's going on. You've got a product code, and it uses It uses vertical bars to separate it uses vertical bars to delimit the values or to separate the values. Sometimes we use commas to separate values. Those are CSV files. Sometimes we use tabs. Sometimes we use vertical bars. And of course, the nice thing about this is that there's nice string functions to split a string like this based on the vertical bars, and you end up with an array. In this case, you end up with a 3-element array. The first element's got the product code, the second one's got the title, and the third one's got the price here. Now, a binary file is different. You're going to see some readable characters in a binary file, but you're also going to see a bunch of garbage and a bunch of stuff that's not readable. That's because you know, it's using it's using a bunch of characters that aren't displayable because it's more compact. It's uses ones and zeros more efficiently, and so on. And so binary files contain more information, but and they can be any kind of information, like a picture, like the pixels of a picture, the 1 and 0 pixels of a picture, and so on. And you don't normally display binary files using a text editor. In fact, you don't. If you use some other kind of you know, application that can translate with the binary file into what it's supposed to be, like if it's a picture or not, or an image or whatever. And this is an example of what it might look like if you were to look at a binary file using a text editor. You'll see some characters that you can recognize, and then there's a bunch of garbage characters that you don't. So there are 2 types of files. There's text files, which contains text strings. The fields of each record are typically delimited by some character, like a tab, or this vertical bar is called a pipe character. And records are usually delimited by a new line. So like in this example, there's 3 records, 1, 2, 3. And a binary file is a file that can contain a variety of different data types. It's you know, just a bunch of 1s and 0s that are interpreted a certain way depending on the program that's reading it. And so so consequently, there are 2 types of streams of data that come in or go out onto the disk and into your computer or into your application. Text stream is used to transfer text data, and a binary stream is used to transfer binary data. So in 128, we did only text files. I think binary files might have been covered in that chapter, but we didn't really spend any time on it because it's a lot easier and a lot more fun to write programs that read and write text files than it is binary files. So these system I/O classes that are used to work with files and streams, there's a FileStream class, which provides access to the input and output files. There's a StreamReader class that is used to read up characters that come from the disk, or they can also come from other sorts of input devices. StreamWriter is used to write out a stream of characters, and that can be writing a stream of characters to a disk or to a printer. There's BinaryReader, and that's used to read in a stream of data, of binary data, and that could be any kind of data. A common file type for binary data that we might see are image files, like .jpg files or .gif files or .png files, and those are just, bunches of binary data, a bunch of ones and zeros, and you use a binary reader to read them up from the disk, and it might be a graphics program that reads up the binary bits and then displays, and it knows what what it's reading is a PNG file, for example. So then that formats, so then that program would format it into a nice picture or a nice image that displays up on the screen that you can see. And a binary writer, of course, would write images. If you have a camera is going to, take a stream of data from the sensors behind the lens and stream those ones and zeros into the little the solid state disk that's plugged in your camera to store the pictures. When you want to display them out again, you would use a binary reader to read that data. So the syntax for creating a FileStream object, which you may remember from last semester, is use the word new, creating a new FileStream, and this is the path to the file. In other words, the disk or the directory, the path, the directory path to the file. This says whether it's binary or not, binary or text, and this is the way that you're going to access it. So in file modes, this can be either append, where you want to, this is your writing now, and you're actually writing to a file that already exists. You're sticking it on the end of it. This will create a file. Create new, I'm not sure what the difference is between that is. This is to open the file. Creating is for writing, and opening is for reading. I'm not sure what truncate is either, but we'll see. Okay, so file access, that's this, can be either reading or reading followed by writing, or writing, just writing. And file share, that's this thing, can be where you're not sharing, or you're reading, writing, or reading. This means that two applications can be accessing the same file at once, kind of thing. And then a common method for the FileStream class is closing the file. When you're all done using it, you want to close it, and that closes it up, and that lets other applications access it. All right, code that creates a FileStream object looks like this. You can first define the path to the file, and then that would be this variable here. And then you create a new FileStream object. This is you recognize this syntax. It's like if you're to create a new list or whatever. You're going to create a FileStream object, and you're going to name it FS. And this declares it. This declares a new FileStream object. This is the constructor. When you define a class, you define constructors. It's how you might initialize a new object of that class when you're defining it. So this is a FileStream. It's a object that you use to access a file, and this is the path to it. There's file mode, and here you're going to create it, and then you're going to write to it. So and so this creates it for writing, creates a new FileStream for writing, and this creates a new FileStream for reading. You create a path. And this says create a new object, create a new FileStream object, and it's this file, and open it up for reading. So, and there's exception classes, or the exception classes for file I/O. When something goes wrong, I/O exception, I don't know, you are not able to access the file, or maybe you can't, the disk is broken or something. Directory not found, file not found. And this is like you're reading, your program wants to read another record from the file, or wants to read another line of text, and it reaches the end of the file, so it's unable to read another line of text. So that's an exception. End of stream exception. So here's some code, try-catch code that shows how these exception classes can be worked, can be used. Let's say we want to access a file. Here's a path, and then here's a file that's in that directory. This is a path to a directory. This is a file that's in that directory, and so we're going to create a new FileStream object, and so this just defines the existence of it. This defines a FileStream object, but it doesn't connect it to anything. And this here we're going to try to connect it. And so basically what we're going to try to do is to set fs equal is a file stream to products.txt, and we're going to try to open it. And it's possible that the file doesn't exist, in which case this exception is thrown, and here it displays out a message saying file not found. Or it could be that this directory, that there is no C# space 2015 / files. There's no directory called that, and that would be, this exception would be thrown. And this says that the file, the path, the directory itself does not exist. And here's an I/O exception. I'm not sure, I can't think of an example right now, but it could be I don't know, maybe it started reading and wasn't able to finish or something. Example of an I/O exception. All right, and for a basic syntax for creating a StreamWriter object is you're gonna it's new StreamWriter. So this is how you create a new instance of it. Here's this is the class, and this is defining a new object of that class, and you would do it this way. You're going to create a new a StreamWriter to write to a text called text out, and it's a new StreamWriter. And inside the StreamWriter, you define the stream to the file, the path, this file stream. Common methods of the StreamWriter class are writing data. This is writer. This is file stream. Yes, okay. And so when you're writing, this writes data. This writes data within a line, or you write lines of data, right? A text file, you write line after line after line, and if you're gonna require several write statements to write a single line, you would use write data. when you use write line, it writes the data, and then it appends the line terminator, which is usually a carriage return or a line feed. It appends that to the end of the line, which makes a new line. And then when it writes again, it's going to be writing on a new line. And then this closes the StreamReader object. So so you need to do this file stream to actually connect it up to the actual file, the path to the file, and then the mode of the file, and so on. Or you may have to create it. And then this text out is actually how you use the methods of the StreamWriter, which requires the file stream. Use the methods of the StreamWriter to actually cause the data to be written out. So once this is set up to the path and to the file that you want, then and this is this text out object has been created. It's a StreamWriter type object. You use the StreamWriter methods to actually write out. And so this, for example, writes the product code followed by the pipe character, vertical bar, and then we write out the product description followed by a vertical bar, and then we write out the price, and we're going to use write line because after the end of the price is written, then we write a return. And then when we're done, and so this is going to write out all of the products all the products one by one in this list of products here. This list of these. And so for StreamReader, you got a couple more things here. You can actually look at the top, or look at what's coming. You can look and see what's coming without actually taking it. Okay, because you can look and see what's coming, and then based on what's coming, you can decide what you want to do. And so peek just returns the next available character in the input stream without advancing to the next position. And if no more characters are available, then it returns -1. So you can peek at the stream all you want. You can peek 10 times, and each time you're going to be seeing the same thing. Nothing will change. It's not until you actually read it where it advances to the next character. So if you do 2 reads in a row, you're going to get 2 different characters. Whereas if you do 2 peeks in a row, you're going to be peeking at the same character all the time, unless you stick a read in between it. This read line will read not a character, but a line, a string of characters up until the return character. So it reads up to the end of the line, reads it in as a string. So this reads the data from the current position of the input stream to the end of the stream. So this reads up the whole thing. I guess this reads the whole file. Returns it as a string. So there's going to be return characters in there. May very well be return characters within this string, because it could consist of multiple lines. And then this closes it. So here's code that reads data from a text file into a collection of product objects. So here we create a list. We're creating a list of products. This is a class called product. We're going to create a list of these objects. And then okay, first we have to define this FileStream thinger, and then we define a StreamReader, and we give a name to it, and then that's what we use. With this name, we are able to use the dot and then the methods that go along with that. And so that's where you're going to use the peek method. We're going to use the read line method, and we're going to use the close method. So here we're reading a text file of products. In other words, we're reading something that looks like this. Okay, 1, 2, 3, these three things, okay. And so we read them one by one, okay. Now the first thing we do is we do a peek to see if there's one there. It's possible that there's not any more lines there. And so if we do a peek and we get back a -1, that means there's nothing left. There's no characters left to read. But if there are characters left to read, then it's not going to return a -1. It's going to return what that top character is. That's okay. We want to read in the whole line. So this actually reads in the whole line from that character up to the next return, to the next return character. So we're talking about where is that? It's back here, isn't it? This on slide 6. So so there's a return character here and a return character here. There's probably also a return character here. So this reads in the first line, and it stores it in a string variable called row. And then, okay, and now we're doing string methods, and it uses the string method split, which is going to return a string array. This is going to return a string array, and it's going to split based on this vertical bar character. And so this is going to return a 3-element array called columns. And in this case, column 0 is going to be this. Column 1 is going to be the title. And column 2 is going to be the price, column of 2. So there's columns 0, 1, and 2, and then what we do is we create a new object, a new instance of a product class, a single one, and that creates that. And then this product class has got 3 properties. It's got a code property and a description property and a price property. And so it's going to store columns of 0, which is the code, columns of 1, which is the description, and columns of 2, which is the price. And it's a text, it's a string of text characters. So we want to convert that string of text text characters, string of ASCII characters, into an actual decimal number, convert it into an actual decimal number, because price is a decimal number. It's not a string, it's a decimal number. So you got to store a decimal number into that property. And so this takes the string that looks like a decimal number, but it's actually a string of characters. And this converts it to an actual decimal number, which it then stores into this property, this decimal property here of this new object, product object, instance of a product of the product class. And then this adds that single product this adds it to the products list, which is this list right here. So we loop 3 times, and then the last time, after we read out the last one, we're going to come back around and we're going to do a peek, and there won't be anything there. So it's going to return a -1. So this will be false, which means it'll drop through, and it closes the text file. And so this is a class that works with a text file. Let's see, what class that works with a text file. So we're going to create a new, this is a path. This is the path to the file. This is a so this is a class. It's called ProductDB, and this is a method. This method is called getProducts. GetProducts is a method, and this method returns a list of products. It returns a list of products. So what does getProducts do? Well, it reads up, just like it did before, just like we just saw. It reads it up. It reads, you know, these products, you know, reads it into a row, does a split, gets an array of, a string array called columns. It creates a new instance of a product object. It stores the first field into this code, second field in the description, third field it converts it to decimal, stores it in price, it adds it to the list, keeps on adding, keeps on looping and adding to the list, and finally it's all done. It's got this nice list of products, and then it returns that. This return is connected with this, so it's this. So if you call productdb.getProducts, and it's a static method, so you don't need to actually create an instance of this product DB class. You can just use it. And so you say productdb.getProducts is going to go out there and read up the products, and it's going to return a list of products. And with that list of products, you can use it to populate a list box or whatever. So this is another static method inside this product DB, inside this product DB class. So you can do product DB dot save products, and it takes a parameter of a list of products, and this thing, you know, creates a file stream with this and that, and a StreamWriter creates a new StreamWriter object called text out, which you can use the methods in text out to write out this thing. So then we loop through all of the products and products in this products list, one product at a time, and it takes the first one, it takes the first property, which is the code. It takes the code property. It's a string, so just use it as a string. We append a vertical bar after it. You know, here we're delimiting the fields using these pipe characters, and then we append, or we are actually writing out, you know, these characters at, you know, one character at a time. No line feeds. This is what writes out the line feed. So this writes the end of the line, and I guess this is going to be implicitly converted into a string, because the price is a decimal number, but this is going to implicitly convert it to a string, I guess. Basic syntax. Okay, so now we're going to look at binary, which is a little bit different. So you create a new BinaryReader stream, just like this. Instead of a StreamWriter, it's BinaryReader, and you call it binary out, and you do the same kind of thing. You got to declare this FileStream thing inside, and here we're going to write, and we don't need to write out. How do we read it back in? Okay, I guess it's magic the way it delimits, which is fine. Here we're looping, and we're writing out these objects. We're writing out the properties, and this we're using the write here, and we don't need to do a write line or anything, because that's text talk. So we just write these values out one at a time. We loop till we're done, and we close it. And basic syntax for creating a binary reader object, same kind of thing. This is creating a binary reader object where we have to have a file stream. So file stream inside. File stream. And these are some common methods. I guess we're just writing out binary like this. Here we're writing this peak, same thing. This reads the next thing, reads Boolean, read byte, read character, read decimal. Okay, so we need to know what these are. And so here we're reading a string. We're reading a string, which is a binary. Okay, so we're defining this reader, and we're calling it binary in, and it's a new binary reader, and here's the stream, this thing. And so we are reading in the list of products. So we're going to create a new list called products. We're going to create a new list of products, product object called products, and it's a new list, products. And we're going to peek at the first character. That's first character of the stream. And if it's not -1, that means there's something there. And so then we loop, and we're going to create a new object, a new product object, which we're going to append onto this products list that we're going to return eventually. Well, this just reads it up into the, okay, yeah, this reads it up into this product list. And here, I guess we're going to return here. We're going to return it here. This gets the products. Here, it's binary. So it's the same as before, except for we aren't dealing with the splitting of strings or anything. We just can read these in and return it. So this parallels, you can see that this parallels reading text files. And we're going to actually do the 2 assignments for this chapter next Tuesday. Today's Tuesday. Is today Tuesday or Thursday? Today's Thursday. Yes, today's Thursday, and then Tuesday we'll do the 2 assignments. There's 2 simple assignments, and then there'll be Thanksgiving, right? Yeah. So this does the same kind of thing. It loops. We declare a binary reader object called binary in. This is the stream. And this is the loop where we loop. We read them in, read in a string, product description. and we read in a decimal number, which is a price. And we are assigning these values to this to the properties of this product object, which we just created here. And then once we're done creating this product object, once it's all filled up with code, description, and price, then we add it to our list of products. And when we're all done with this while loop, we just close the stream and return the products, because this thing returns a list of products. And here's how we write it back out again. Same idea. We loop, create an instance of this binary out. This is the stream. We loop through all the products. Each time we write out the code, the description, the price, go on to the next one, code, description, price. And then when we're all done, we close the stream. So anyway, that pretty much covers the text, so that creates the, or those are the slides for this chapter. Simple. The thing you are learning new is binary files. They would be more compact. It uses less bits for the data because we aren't limited to just ASCII characters. And so in the next, on Tuesday, we will do the two extra exercises at the end of chapter 21, which will be a simple read-write text file application, and then a simple read-write binary file application. So, all right, so are there any questions? All right, thank you for coming to class, and thanks for watching.